we are here at the beginning of 4.2 binomial distribution, and we're finally going to start putting some of these ideas together that we've been talking about today. Some of these concepts we've been talking about in chapter 3 and beginning of 4 are kind of seeming a little repetitive, but now we're going to put them all together. So here we have 4.2, and it's how to find the probability of a binomial experiment. So I just typed these in right now. So I wanted to kind of talk through it as we wrote it, but I didn't want you to see how spazzy I was at typing it. But here, one way to write this, probability of a binomial experiment with a number of successes in a certain amount of trials with a given probability. So if you see it written like this, it's not that common, but if you see it written like this, just kind of have this sheet handy and see that X comes first, N comes second, P comes third. And right here we have N, same as always, the total number, or the number of trials, the number of numbers. X is the number of successes, and then P is the probability of one success. And so we're going to plug that in. We have this notation from before, N choose X. We called it N choose R before, but N choose X, N choose R, N choose K. It doesn't matter what variable the second one is. We want to use X right now because it's the number of successes. And then we have P, the probability of one success to the X power, times the quantity 1 minus P, so that would be the probability of failure, to the N minus X power. And we're going to be able to type all of that into the calculator. So again, N is the total number of trials, X is the number of successes, and P is the probability of one success. So as a reminder, this N choose X notation is the same as the big parentheses and the N over X, just not a fraction. N choose X, like I said, N choose R. Okay, so let's just try one real quick, and then I want to show you something else. So let's try this first. So it says a coin is flipped 7 times. So N is 7. We have 7 trials here, just flipping it N times. The success is flipping tails, and it doesn't tell us the probability, but we've done heads and tails before. So for this one, the probability is a half, is heads is a half, tails is a half. And what is the probability of getting 4 successes? And so that is going to be our S, the X, the number of successes. So the question is asking for the probability of X. And the probability of X is going to be, from this notation above, we're going to have N choose X, so 7 choose 4. Get my fancy parentheses. I guess you're still going to see how bad I am at drawing this because I have to do it every time. Okay, 7 choose 4. And then we have P, our probability of success is 0.5. And that is going to be raised to the X power. So it's going to be raised to the 4th power. And then finally, we're going to multiply that by 1 minus 0.5. And here, yes, we know it's a half, but I just like to do the 1 minus because sometimes it's more complicated and I don't want to think that hard. So 1 minus 0.5, and that's going to be raised to the N minus X power. Okay, that's kind of weird looking. I'm going to type it in the calculator so then it's more clear what it's supposed to look like. So as a reminder, we go to the toolbox. And I was just using this, so let me go back. Yours is probably going to look like this, like all the way at the top. So as a reminder, we want to go down to probability, hit over, combinations, hit over, and then here it is, the combination N choose K. And so this is 7 choose 4. I'm going to type that in. Now, I like to use parentheses, especially because the second part has that subtraction. So I have parentheses 0.5, and to raise it to the 4th power, we're going to use this, the second button down. It says X to the Y, and when you push it, it raises it to the power, so I can just type in 4. Then I want to hit over, because right now you can see the cursor's up by the 4 and I want it down and make it big again. So I have 1 minus 0.5. And again, I want to raise it. So I click the power button, 7 minus 4. And there's the answer. So this said to round it to 3 decimal places. So I have 0.273. Voila. I'm excited. Okay, so that's the probability of, oops, I wrote X, probability of 4 is 0.273. Okay, let's just take a quick pause, not really a pause, just a shift over to what the homework will look like. And then we'll go back because it'll start off looking a little different and then it'll look like what we just did. So here's the question, and it says in a large population, about 20% of children have a food allergy. A researcher takes a random sample of 85 children and surveys whether or not they have a food allergy. We want to use our binomial distribution to compute the probability that exactly 15 of the children have a food allergy. Okay, so N, how many trials? That's the big number. So they surveyed 85 children. X is the number of successes. So we're looking to see how many, in this case, a success is having a food allergy because that's what it tells us. It tells us that 20% of the children have the food allergy, and we're looking for 15 of the children having the food allergy. So that's our success. And the probability of a food allergy is 20%. Remember, it's always as a decimal. Probability is always between 0 and 1. So we type in 0.2. Okay, that's what we just did. So that wasn't really the exciting part. But I wanted to submit that because then part 2 of this question is a little different. So now we're going to visualize what we just talked about. So we're going to use the same numbers. This is the same problem. So we said, I'll keep it up there so you can see it. It said N was 85. So we're going to scroll this over. Hopefully you're just watching right now because then when you do this on your homework, then you'll see what to do. The probability of success we said was 20.2. And we want to know about 15 people having a food allergy. So it says right here, the probability of 25 successes out of 85 with our probability is given right here. Well, I want to change the probability to 15 successes. So I'm going to move my success over to 15 because that was our X above. So it's on the x-axis, and so it says a probability of 15 successes in 85 trials with a probability of success of 0.2, which is exactly what we're asking, is 0.0969. So this answer will be, almost got it wrong, 0.0969. I don't think it says to round. I think it just says to type that in. Okay. So the probability is displayed right here. So that way for these problems, you're just visualizing on this graph. You're not having to type in the whole formula. Submit, and woohoo, we got it right. Okay, so, oh, it does say it round, but I typed it in exactly how I thought and it didn't matter. Okay, let's go back. So going back here, we have another problem. We're gonna do a few like this just to get the hang of the formula, and then we're gonna do some trickier ones. So this one says a deck of cards each has 26 letters of the alphabet. Each has one of the 26 letters. Okay, A, B, C, D, E. Success is defined as drawing a vowel, A, E, I, O, or U, so we don't have to worry about why. They're defining what a vowel is written on the card. If you draw 5 cards with replacement, what is the likelihood that none of the cards will have a vowel on it? Okay, so we have 26 total cards, so that's N. We're drawing 5 cards, so where's my arrow? So X is 5. And then it says we're drawing them without or with replacement. So we draw a card, stick it back in. Draw a card, stick it back in. It has to be like this for binomial distribution. We have to have the same probability throughout. So if we did it without replacement, that would mess with the probability. So drawing a vowel, we know that there's 5 vowels. Drawing a vowel out of the 26 cards is just 5 out of 26. That's the probability of drawing a vowel. We're putting it back in, and the next time we can draw another vowel or a consonant, we don't know, but the probability is going to be 5 out of 26. This formula up here doesn't say that P has to be a decimal. I don't know why I'm leaning in so hard to this camera. It doesn't say probability has to be a decimal. It could be, so I'm just going to leave it as 5 over 26. Oh, I will put a P here just so we know what it is later. This is my lowercase p. And there's a little extra over there. Oh, lowercase. It's just weird how it switches like automatically to text when I click the wrong button. Okay, that's P. This little sign is kind of confusing. It is nothing. Go away. Okay. What is the probability? What is the likelihood? Okay, that none. We're looking for none right here. None of the cards has a 5. In other words, P of 0, capital P. So we're looking in this problem for P of 0. So in this one, oh gosh, I was so excited about my arrow that I didn't even think this through. We're just drawing 5 cards. That is not X. I apologize. That X has to do, I mean, the 5 has to do with the probability. None, that's what a success is. We want 0 vowels. And so therefore, at this none, I'm just trying to get my money's worth out of this arrow today. None, go back to my arrow. Okay, I am a little too obsessed with this. None is, okay, I'll stop, I swear. None is telling us that X equals 0. Again, the 5 over here is just simply telling us that it's 5 out of 25. What is the 5 telling us? Yes, okay. Are you yelling at me yet? Did I mess this up enough yet? Sorry. 5 is the number of trials. 0 is the number of successes. We're not drawing 26 cards. Goodness gracious. It's like my first day on the Zoom over here. 5 is our N. 5. We're drawing 5 cards. Total cards is 5. Sorry about that. 5 out of 26 is a success, and none of them is what we're looking for. We want X to be none. Okay. Now that we're all thoroughly confused, let's plug this in the calculator. Okay, so we have the probability of 0 would be 5, choose 0. So 5 cards, choosing 0 of them to have vowels. And so I'm going to put my giant parentheses around. They're looking worse and worse. Giant parentheses. Okay. And then we have 5 out of 26 is our probability of success. That's a fraction. So I'm going to draw my fraction bar under it. 5 out of 26 is the probability of success. And that is being raised to, okay, that's fine. I just need to get a little bit out of the way. That is being raised. Can you guys just talk for me? Can you fill in the blanks? Okay. This is being raised to the X power. What is X? 0. I'm not even going to mess with that anymore. X power is to the 0 power. Now, what is the other one? I don't care. I'm not actually going to do the subtraction. I'm just going to type out myself 1 minus 5 out of 26. Make that one a little bigger because it's just a 1. This will look better when you see it in the calculator. I'm not having a good PDF day today. Okay. 1 minus 5 out of 26. Put my parentheses around it. Put my parentheses around it. There we go. wow, this is just not my day. Okay, well, let's pretend there's another parenthesis over there because I did not want to take 5 more years to type this up. N minus X, 5 minus 0. This will look a heck of a lot better when we type it into the calculator right now. Parentheses. Okay. Ugly, terrible. Let's type it in over here. So we have, go back to our toolbox. Remember, once you use it, it's right there for us. And choose K. 5, choose 0. 5 cards, we want to choose no vowels out of that. I have 5 over 26 to the 0 power. Remember the to the button is right here. Times 1 minus 5 out of 26. Now I just typed in 1 minus 5 divided by side 26. Make sure it looks like this. Don't have the 1 on top. We want the 1 on the bottom. And we want that to be raised to the 5 minus 0 power. That is a lot of work to put that on the PDF. I might just write it over here in the calculator in the future because it looks so much better. And we have our answer. Okay, we don't need the fraction. We just want rounding to 3 decimal places like the problem says. And it says 0.344 rounding because that 7 rounds up this rate. Beautiful. Love it. There's our answer. Okay, let's try this again. Here, we have a very similar problem. And so what I want to do, instead of me, let's just stop this. Instead of me just like telling you what to do every 5 seconds and you just watching me fumble with everything, pause this video and then try it on your own. And then when I come back, I'm going to have it all written out for you so you don't have to see the awkward me typing. Okay, sound good? Okay, pause the video. All right, so hopefully you paused the video and you have, oh, no, I can't start my video. Oh, here I am. Hopefully you paused the video and you worked through that problem. I am now going to show you what it looks like and do it in the calculator. So here we have percentage, or the probability is 52%, which again is a decimal. We're going to write it as 0.52. There's a total number of 5 people being sampled, and 4 of them is what we're looking for. So 5 choose 4, 0.52 to the 4, and then 1 minus 0.52 to the 5 minus 4 power. So going here to my toolbox, I am going to do 5 choose 4 times 0.52 to the 4th power times 1 minus 0.52. Now, I could write 5 minus 4 like we have been doing, or sometimes you're just like, I know it's 1. I'm just going to write 1. It's fine either way, whatever makes you happy. And so we have this to 3 decimal places, 0.175. Okay, so this is just going to be a lot of using the same formula over and over again. But every time it said, like, what's the probability of this many cards or this many fast food or what order food to go or whatever. Now, in question 4, it's a little different. You're going to notice the phrasing at least 1 head. Okay, so we're flipping a coin 9 times. Success is flipping heads. This is very similar to, okay, similar to that one, but not the same. Success is flipping heads. Round your answer. What is the probability of flipping at least 1 head? So that's out of 9. So before we do this, let's just look at the numbers from 1 to 9. Well, actually not even that, because we could get 0. How many heads could we get if we flip it 9 times? We could get 0 heads, 1 head, 2 heads, 3 heads, 4 heads, 5 heads, 6 heads, 7 heads, 8 heads, or 9 heads. Okay, those are all the possibilities that we can get. At least 1, well, Remember, like you have to be at least 16 to drive. Wait, where is, am I not sharing my screen? Did I not share it right? Oh my goodness. Hold, please. I don't see my face in the corner. Have I just been making big faces to you? I apologize. Okay. How about now? Sorry. Okay. We'll fast rewind a little bit, or not rewind, pause it. That was the answer to number 3. Okay. Number 4. At least one head. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the possibilities. At least one, remember, like you have to be at least 16 to drive, is 16 and over. So at least one is 1 or over. So that is, my friend, quite a lot. That would be 1 or bigger. So this is saying, what's the probability of getting 1 plus the probability of getting 2 plus the probability of getting 3 plus the probability of getting 9. All of those. I'm not writing all of those out. That's like a bazillion. So the answer is not a bazillion. It's just a bazillion minutes it's going to take me to do that problem. Okay, so another way to think about this, instead of saying, let's do everything from 1 to 9, we could say, well, everything, why are you not changing colors? Everything, huh. I don't know why it doesn't want to change colors. Oh, there it is. What in the, okay, whatever. Now it's extra colorful. Everything is from 0 to 9. I want 1 to 9. Everything is 1. Remember, the sum of the probabilities adds up to 1. The whole thing adds up to 1. So I could say everything minus the one I don't want. I don't want 0. I want everything, take away 0. Not literally take away 0, but take away this probability of 0. So everything taking away that probability is going to leave you with the probabilities that we want. Why is that so helpful? Because it's a lot easier to figure out the probability of 0, and that's it, than it is to find the probability of all of the other stuff. Okay, so let's go back and find our letters. We have N. It's 9 times that we did it, 9 trials. Success is flipping heads. Just like the success of tails, it's 0.05. X in this example, so this is part A, X is 0. Why is X 0? Well, we just talked about it over here. X is 0 because I actually am going to do everything minus that 0, probability of 0, to get to the answer I want. So, calculator. 1 minus the probability of 0 is, look at my toolbox, it is 5 to 0 times my P to the N power times my P to, well, I mixed one. That's actually to the X power. X power, and then this is to the N minus X power. Double check. Yeah, P is to the X power. Okay, P is to the 0 power. So I have 1 minus all. Now this is all times, so it's okay to have it written like this, but if you would prefer, you could always just give it a big old fat parenthesis so you know for certain that it's subtracting the right thing. And we get a nice big number because it's a pretty high probability that I'm going to flip ahead at least 1 time. What is it? We're doing 3 decimal places, 0.969. So this is the answer to part A. Is 0.969 because, like I said, most likely, very likely that you're going to get at least one head. It's very rare that you're going to get no heads. So that was a much faster way to deal with at least. Okay, let's think about this again. This time we are going to do, I really hope this changes colors. This time we are going to do at least 7. So this time, get rid of this. Ooh, wrong, the wrong thing. Get rid of my rectangle. No, it won't let me. I'll just draw on top of it. This time we want only 7, 8. Bro, is that really what it thought I wanted? Goodness gracious. Fill, nothing. Border, this. Okay, you want to see me lose my mind? I think it is happening quickly here today. What, just opacity 0, I guess? Okay, border, okay. At least 7 heads. Good highlight. That's it. I don't even care if it marks it this time. At least 7 means 7 or 8 or 9. It's 7 or bigger. So I don't want, there's not really like a shortcut. There's just like the faster way or the longer way. In this case, the highlighted 7, 8, 9, that's only 3 numbers. So I have to do this 3 times. The unhighlighted numbers, 0, 1, 2, 3, 4, 5, 6, that's 7 numbers. So I could do this 7 times or I could do this 3 times. So the faster way to do this problem with at least, in this case, is simply to do the probability of 7 plus the probability of 8 plus the probability of 9. That's the fastest way that we're going to get through this problem because the other way takes 7 problems. So we are going to do this whole problem with x is 7. I'm just going to kind of narrate what we're going to do because I'm going to type it in the calculator. So we will do this the whole formula. Do the whole formula with n equals 9, p equals 0.5, just like before, and n equals 7. Okay. Then step 2, do the whole formula, but this time we're going to do it with n equals 8. Step 3, this is going to go pretty fast on the calculator. We're going to do the whole formula, but this time with n equals 9, and then finally add them all together. That's what we're doing in Word. Okay, calculator time. Let's do this whole formula with n equals 9. Did I do that last one wrong with 5? What is wrong with me today? It literally says n equals 9 and I did 5. And 9, 2, 0. Why did I do 5? You guys haven't stopped watching, have you? Obviously, I am just off today. That's the answer. What is going on? 998. Don't email me. I know I messed up. Okay, we got this. Let's do this one last time. And then, yeah, then we'll talk about the fastest way to do the other one. Let's just clear. Let's just start fresh and just get rid of everything. Let's do this whole formula with n equals 9, p equals 0.5, and n equals 7. So going to my toolbox, I want 9, choose 7, 0.5 to the 7. Did I write n twice? Guys, what is wrong with me today? Like literally, what is wrong with me? You know what happened? I'm going to tell you what happened. I'll tell you what's wrong with me. I woke up early and I just taught 2 hours in a high school classroom. I don't just mean like high school online. I literally went to a high school classroom and I taught them for 2 hours. And so I'm blaming them for literally everything, every typo today. I'm sorry. This is ridiculous. And if I wasn't already like 30 minutes into this video, I'd probably just delete it and try again. So hopefully I have not messed up anyone too much. But we have 927, a half to the 7th power, times, let me go back here, a half to the 9 minus 7th power. Okay, that's the answer to the first one. We can write it down if you want. We don't need to. I'm going to show you 2 different ways. So I'm just going to write this down. This is round to 3 decimal places. 0.070. Okay. I was just so excited to show you this shortcut that I just made little mistakes. So here we go. We're going to go up and we want to do this problem again, but with 8. So I'm going to copy it. So what I did was I went up, hit up twice, and I'm going to hit enter. And it copies it. And it's not exactly right, but all of these 7s are going to now turn into 8. And that's an 8. And that's an 8. And I have my second answer. Again, it's not necessary to write this down. I'll show you why at the end, but I'm just going to do it for right now so we don't get, so we can see that there's 3 different answers and then we're going to add them together. Try this one last time. Go up, copy, change all my 8s to 9s. And ooh, that's a tiny one, 0.002. And I want to add that up. And this isn't terrible. Adding that up, I could probably do it in my head. It's not that bad of a number. But 2 things are going on. One, I rounded each time, which could affect the final answer. When you round too early, it could affect the final answer. And 2, it was just an extra step. Because if I didn't write those down, I would have them all still in my calculator, and then I'll show you what we can do. So I want to add up these 3 numbers without writing them down. I go to my calculator, and I say, here's the first answer, because we did 927 first. So I'm not choosing the equation. I already did that. I'm now selecting the answer, and by highlighting it and hitting execute, it copies it for me. So then I hit plus, and now I'm going to go up to take this answer because 9 choose 8 was the second problem. So I'm going to go up to this answer, hit execute, hit plus one more time. You have to hit plus in between so it knows we're adding. And this time I'm just going to go up to the last answer right there, hit execute. I don't know why. It gave me a fraction earlier when I tried this too. I don't know why. It doesn't matter. It won't affect the answer. Bada bing, bada boom. And we get 0.090 to 3 decimal places. So I guess if we had chosen to add these all up, or if we did it this way, we would have gotten the same answer to 3 decimal places either way. Fabulous. It's just a little faster. So you don't have to like write down, because sometimes people want to write down this whole number, which is fine, but then it just leads to more mistakes later. Okay, number 5 and number 6. I'm going to give you some time to try those, to practice them, because this is tricky, and I want to give you some time without me talking so much and possibly me saying the wrong thing. I'm going to do them, and I'm going to double check them, and then I'm going to come back, and then you're going to come back, and we're all going to talk about the answers. All right, pause the video, try the calculator, try the paper, everything by yourself, and then come back, and I will talk about them. Okay, I'll be right back. All right, hopefully you had a chance to pause it and try them. And now let's talk about the ones that I got. So here, I'm going to share. I remember to share this time. I didn't actually finish them, but I just did a lot of them so we could do the calculator part together. All right, so number 5, the probability was 80%, so 0.8. And it was 10 people are 10 people are randomly selected, so that's our N, our total number of people selected. And we want to find the probability of at most 8. At most 8, that's the opposite of at least. So at most 8 could be 8, but it could be 7, 6, 5. It's just 8 is the most, all the way down to 0. And so I listed all the numbers here from 0 to 10, and we could do probability of 0, probability of 1, 2, 3, all the way up to 8. So that would be 9 different problems. Or just like before, the whole thing, all the way to probability of 0, all the way to probability of 10, that whole thing adds up to one whole 100% probability. So it'd be easier to do 1 minus the probability of 9 plus the probability of 10. So whatever these two add up to, do 1 minus that and we'll get our answer. So I did the probability of 9. So I have 10 choose 9, 0.8 to the 9th power, 1 minus 0.8 to the 10 minus 9th power, and I got my answer there. And then I just typed in probability of 10. So 10 choose 10, 0.8 to the 10th power, 1 minus 0.8 to the 10 minus 10 power. So that gives us that number. And so our final answer is going to be 1 minus, and now I want these in parentheses because I want the probability of 9 plus the probability of 10 as that sum, 1 minus that sum. With the distributive property, we need to have the parentheses there. So 1 minus, go up and grab the probability of 9, which is that 0.268 number, plus, go up and grab the probability of 10, which is right above. Weird, isn't that weird how sometimes it gives me the fraction and sometimes it doesn't? It's okay, it doesn't matter to me. It'll give me a decimal in the end. So I have my parentheses, they are closed, and I hit enter, and here is my probability. I have to 3 decimal places, 0.624. So again, I just did 2 probabilities, 9 and 10, and did 1 minus that. Okay, so this little shortcut is at least, at most, knowing that everything adds up to 1, as we saw in 4 and 5, could be very helpful. Number 6, not really either way. Because look at this, it says, okay, 5% of all visitors are looking for other websites. So there's our probability, or probability of success is 5%. They sampled 5 visitors, that's our N, and at most 2. Oh, notice over here I put at most 8, and I put x equals question mark because we weren't sure what we were going to do. So again, 2 x equals question mark. And so we have our probability of 5%, 0.05, and our N equals 5. Give me my, I'm glad I paused it because I feel less flustered than I was at the beginning. I do want to I said this out loud, but I want to just type this as a reminder. 5% is 0.05. 1/2, 50% is 0.5. So we need that extra 0 because it's like a nickel, not a half dollar. Okay, there are 6 different probabilities. Excuse me. 0 to 5. We want to know at most 2, so 0, 1, or 2. But the other side is just 3, 4, or 5. So do I want to do these 3 probabilities or these 3 probabilities? I said it was easier to do these 3, 0, 1, and 2, because if I did it the other way, versus I would have to do 1, because this isn't what I want. I don't want the 3, 4, or 5, so I'd have to do 1 minus parentheses probability of 3 plus the probability of 4 plus the probability of 5, close parentheses. So it's just a little extra work because you have to do that 1 minus and you have to make sure the parentheses are there. That's why I said it would be easier to do 0, 1, and 2. Okay, so last one for this video. We have the probability of 0. So hopefully you're expert at finding all of these buttons now, and choose K and choose R. So the probability of 0 is going to be n choose 0, 5 choose 0, times 0.05 raised to the x power, so to the 0 power, times 1 minus 0.05 raised to the, what is it, 5 minus 0 power. That's the first one's really the hardest, because once we type that in, hit enter, now I'm going to go up and I'm going, so the probability of 0 people coming to this website and actually looking for other web pages is pretty high. I mean, probability that they're not looking. Yeah, the probability that nobody is coming to this web page and actually meeting another one is pretty high. That seems right. Usually you go to the right web page the first time. Occasionally you go to the wrong one. Okay, so I'm going to highlight this. Remember, I just hit up, up, enter. And I'm going to change all the zeros to 1 because now I'm doing the probability of 1. And again, up, up, enter. Change everything to a 2. Oh, that's on 2. And last but not least, as one final reminder, I am doing this guy right here. So I don't need to do the 1 minus. I'm just going to go up, grab my probability of 0, plus sign. Go up, grab my probability of 1, plus sign. Last one, they're going to give me the fraction again? Probably. Fraction. Equals, I have, oh, you can't see what I'm pointing at. Probability of 0, probability of 1, probability of 2, enter. So going to a website, and at most 2 are looking for the website we mean for them to be looking at, that would be 99.9, very high. That, oops, sorry, I went to the wrong page. Let me just type in this final answer. The probability of those 3 things is 0.999. I do not know why that little weird arrowhead is there. Okay, there we go. No, it's not going to throw it away. Okay, 0.99 because of that 8, 8. All right, hopefully I did not make it worse. Hopefully you're starting to get the hang of it once I remember to, share my screen properly and type the right buttons in my calculator. Hope you have a good rest of your day, and I will see you in the next video. Bye.